Yeah, hello everyone. Welcome back again to Maruthi tutorials. Myself Maruthi. I'm going to explain a concept dealing with the Remainder Theorem. Okay now. So the concept is Remainder Theorem, right? I'm going to tell you a concept. It has many applications. Of course, as you all know, factor theorem is also an application of Remainder Theorem. So a concept is Remainder Theorem and the application is factors theorem. Today I am going to give a proof for you regarding the Remainder Theorem. So right, let us come back to this one. Right, mainly saying it's Remainder Theorem is nothing but mainly the bottom line here. Right, if f of x is divided by x minus a, then the remainder is f of a. That straight away come to the Remainder Theorem. If f of x is divided by x minus a, then the remainder is f of a. Then what is f of a? It's nothing but a constant, a number. Right. So fine. Now let us come back to the first slide. What is this p of x? Of course, p of x is a polynomial. Right. Of course, we have conditions for polynomial also. Right. P of x is a polynomial. Now, what is this a? A is nothing but the real number. That's the two concepts. So, Remainder Theorem says straight away only one thing. If p of x is divided by x minus a, then the remainder is p of a, which is nothing but a constant. Constant may be a number, a k, whatever. Now, what is p of x? P of x is nothing but a polynomial and a is nothing but a constant or a real number. Now, let us come back to the degree of the p of x. Degree of p of x, it should be must greater than or equal to 1. Means it should not, right, it should be, the degree should be the degree n. Let us consider it as greater than or equal to 1. Now comes the Remainder Theorem. If a polynomial p of x is divided by x minus a, then the remainder is p of a constant. Okay, now let's prove that one. Let us prove that one. Now let us consider the polynomial. Right, suppose a polynomial p of x. Let's suppose a polynomial p of x, and what is the condition? What is the condition? Degree of the p of x greater than or equal to 1. So what we have considered? We have considered a polynomial p of x, and the condition is the degree of that polynomial should be greater than or equal to 1. First point is considered. Now let us take one more conditions. Now let us take one more consider. Consider a polynomial. One more polynomial. I like to call it as g of x. I like to consider a polynomial g of x, and that g of x is nothing but x minus a. Right? So we have considered two things here. Right? The first one is we have considered a polynomial p of x. Right? And we have considered one more polynomial, that is nothing but g of x. Right? The first condition, what I said, the degree of the polynomial p of x should be greater than or equal to 1. Now comes the tricky part. So as we have considered g of x is equal to x minus a, here the main concept, the way what we are supposed to take g of x should be the degree of the p of x should be always greater than the degree of g of x. That is, degree of p of x should be greater than degree of g of x. Right? It may be or equal to also we can take. So, right? The degree of p of x, it's greater than or equal to degree of g of x. And very important point, g of x should not be equal to 0. So, when we are considering g of x, these are the 2 points what we have to consider on. That is, the degree of g of x should be less than or equal, or degree of p of x should be greater than or equal to degree of g of x, and g of x should be always not equal to 0. These are the two conditions what we are taking. Now, yes, what we are saying now, when p of x is divided by g of x, that is g of x, which is nothing but x minus a. G of x we have taken it as x minus a. Now what we are doing? Now let's divide this p of x with g of x. right? When g of x, then p of x is divided by g of x. Now we have to think about other two factors. That is, when p of x is divided by g of x, then what's the quotient and what's the remainder? These are the two things we have to think on, right? When p of x is divided by g of x, what is the q of x and what is r of x, right? So let us assume that, as we have considered here, when p of x is divided by g of x, let quotient is equal to q of x, let us take that, and remainder, right, reminder, it is nothing but r of x. Let us take the quotient as q of x and the remainder as r of x. These are the two things. So let us recall. What is the first point we have taken? We have taken polynomial p of x. What's the degree of that? Degree of that one. The degree of p of x should be greater than or equal to 1. Must greater than or equal. What we have considered? We have considered a polynomial g of x, and we have taken g of x as x minus a. Of course, that a is nothing but the real number what we have taken. Now, what we are doing here, of course, the tricky part, what is the degree of the p of x? It should be always greater than or equal to 1, and g, the one which is dividing, should never be 0, right? Now, when p of x is divided by g of x, what is the quotient and what is the remainder? Let us consider the quotient as q of x and the remainder is r of x. Now, one more point to be noted now. Right, here degree of who is that? Right, the g of x should be greater than degree of, what is that? R of x. The remainder, whatever we are getting, obviously will be, the degree of this remainder will be less than the degree of g of x. So these are all the conditions. If you check it out, g of x should have degree less than p of x, right? And the remainder whatever we are getting, it should be less than the degree of g of x. That is what we are considering now. Now, applying division algorithm, if we know this one, right? That is, if you take 7 divided by 3, 3 2s, 6, that is the remainder, right? Now, how can we write 7 as? We can write 7 as 6 into 2 plus 1. Is it that? Now, if we apply the same logic there, that is nothing but a division algorithm. According to division algorithm, right? What we are having, the p of x is equal to g of x into q of x plus r of x. That is g of x into q of x plus r of x. Right? This is the concept of what we know according to the division algorithm. If you check it out, p of x equals g of x into q of x plus r of x. That is the division algorithm, what it is helping us. Now, out of this total, but we already know the degree here, what is nothing but g of x here. G of x we have already taken it as x minus a. Let us plug in there. Let us plug in the value of that one as we have already known that. So, p of x is equal to, in the place of g of x, let us plug in x minus a into q of x plus r of x. Right? This is what we are having now. Now, if you check it out, what is the degree of here? Degree of the g of x is equal to 1. Right, the degree of g of x is nothing but 1 here. Then, as I said you just now, the degree of g of x, right, or the degree of r of x should be less than g of x. It should be, the degree of r of x should be less than. So, degree of r of x should be less. Should be less. Right, less than what? Less than what? Here, the degree of r of x, we are taking it as, the degree of g of x, we are taking it as 1. Then what should be less? If you check it out, right, let's go for that. Let me explain you with the help of one more concept. Right. So the degree should be less. If the degree of g of x is 1, then what might be? It should be less. What is less than 1? So here as it is less than 1 means 0. Degree should be less, which implies degree of r of x is equal to 0. Why? The degree of g of x is 1. If the degree of g of x is 1, then 1 less than that 1 is always 0. Right? So degree of r of x is equal to 0, which implies what is the degree? If the degree is 0, what do you call it as? If the degree is 0, we call it as a constant, right? Which implies, right, it's nothing but a constant. Right? Why? Because if you take a number 4, right, what's the degree of that? So beside that, if you doesn't have, it's nothing but x, and the degree is 0. So that, therefore 4 into 1 equals 4. That is what? So degree of r of x, what we are taking, it is nothing but 0, which is nothing but a constant. Let's say it as k. Right. So now degree of, right, what is the term what we are taking? It's a constant. Degree of r of x is equal to 0. Therefore, we are taking the remainder as a constant and let it be k. Now, let us substitute the value of k in the division algorithm, whatever we got there. So, which implies p of x is equal to x minus a into g of x plus k. Okay, so we got it as a constant there. Now let us consider few more things now. Right? As we all know, in the place of x, let us substitute a. Let x is equal to a. Let us check it out. Now if you substitute p of a, it's nothing but a minus a into q of x plus k. Right? A minus a is 0. P of a is equal to 0 into q of x plus r, which is not p of a is equal to a constant. That is what we got. So it's nothing but a constant. It's nothing but, it's hence proved. Right? I like to repeat, it's a tricky part. Let's go in a way. If p of x is divided by x minus a, then the remainder is p of a. Means p of a constant. That's what we are saying. So what would we take? We have supposed a polynomial p of x, but the thing you have to remember, as he has given in the question itself, your theorem statement itself, the degree of the p of x should be greater than or equal to 1. Yes, that is the first one. Now we have considered a polynomial g of x, and what's that? X minus a. And remember, the degree of this one is nothing but 1. Now, that's what he says. Degree of the p of x should be greater than or equal to degree of g of x, and never g of x should be 0. This is the consideration we have to take. Now, right, when p of x is divided by g of x, that is nothing but x minus 1, the degree, the quotient will be g of x, q of x, and the remainder is r of x. Now, the one more tricky part, the degree of g of x should be greater than degree of the r of x. Now, applying division algorithm as I have showed already. So, you write, this is division algorithm, p of x is equal to g of x into q of x plus r of x. Now, right, what is the condition what we are having? In the place of g of x, we are applying x minus a, right, and applying the logic that the degree of that one is already, the degree of g of x is 1. So, less than that one means degree of r of x should be less than that one, and the degree should be 0. If the degree is 0, what do you call? It's nothing but a constant, and we like to take that constant as k. Now let us substitute the value of k there. We got it. Now for suppose in the place of x I am taking a, right? If you simplify, we got the constant as k. So when p of x is divided by x minus a, the value of that one is nothing but a constant, that is k. Thank you. Hence, bro.